Society weekly webinar series, jointly organized by IEEE Kerala Section, the Institution of Engineers, Kerala State Centre, Computer Society of India, Trivandrum Chapter, Project Management Institute, Kerala Chapter, Intersociety, Trivandrum Chapter, Vakum Malawi Foundation, Trust, Trivandrum, Life Member Affinity Group, IEEE Kerala Section, IEEE Engineering in Medicine and Biology, Kerala Chapter, the Institute of Electronics and Telecommunications Engineering. Before we begin the session, I kindly bring your attention to the feedback link that would be provided along with the mail hosting the Zoom link. And except for the speaker, all participants, please make sure that your audio and video are off throughout the session. And after the session, we'll be having a question and answer session. So all the participants are welcome to post all the queries and questions in the chat box. And the selected queries will be addressed by the speaker after the session. Now moving on formally, I welcome Gokul to welcome the virtual gathering. Gokul, please.
Hello, am I audible?
Yes, Gokul, you're audible.
So, good evening, all. A warm welcome to you all to the 102nd Intersociety weekly webinar series. First of all, I would like to welcome our speaker, Mr. E.R. Madana Mohan K. Sir, Deputy Chief Electrical Engineer, who will be giving a keynote on Indian Railway, a net zero carbon bid by 2030. Then I would like to welcome our chairman, Sir, Mr. Ravindranath Sir, who helped us to conduct the previous 101 webinar smoothly. And I would like to welcome all the delegates who are present here and all the participants who are attending this webinar. Thank you.
Thank you, Gokul. So now I call upon Gokul Raj for the introduction to the speaker. Gokul, please.
Am I audible?
Yes, Gokul, you're audible.
Now I would like to introduce Engineer K. Madana Mohan, Deputy Chief Electrical Engineer Railways. He is retired now. He graduated in Electrical Engineering from NSSC Palakkad in 1978. He joined Integral Coach Factory, Chennai in June 1979 and worked there in various capacities like AE, Works Manager and Deputy Chief Electrical Engineer in manufacturing of ACMUs, DCMUs, DEMUs and other special coaches. He had also worked in plant and machinery maintenance as a Deputy Chief Electrical Engineer and also maintained 7 wind turbines of 1.5 megawatt capacity each at Tirunelveli district owned by ICF.
Thank you, Gokul. So now let's move on to the session. So please take out the session.
Okay, shall I start?
Yes, sir, you may start.
Am I audible to you?
Yeah, you can, sir.
Yes, sir, you're audible.
Okay.
Yeah.
Good evening to everybody. Good evening to everybody. At the outset, let me thank Dr. Ravindranathan, IEEE Intersociety Activities Committee Chairperson, and all other delegates who are present for this webinar. Actually, I'm happy to have a technical presentation on webinar platform, and I've been privileged to do so. So the topic which we are going to discuss is Indian Railways, the national transporter, a net zero carbon emitter by 2030. Before we delve into the specifics of IR, Indian Railways, we would let us understand the background or what is the provocation for transitioning from normal carbon massive to net zero carbon or carbon neutral. That provocation, what is the actual provocation? Let's see that. So you are all aware that due to more and more urbanization and more industrialization, there is an ever growing demand for energy on one hand, and there is a rapid depletion of fossil fuels on the other hand. And if you continue to burn fossil fuels at this rate, the whole reserve of fossil fuel will last only for another 100 years or so. So you can't afford to have that liberty or luxury of burning fossil fuels at this rate. Moreover, you have to preserve these fossil fuels for future generations. And you all know, to recoup or replenish these fossil fuels, it takes millions of years. So this is one side of the story. The other side of the story is, if you burn more and more fossil fuels, it is detrimental to the environment. It gives rise to GHG gases and leading to global warming, and finally resulting in climatic change. And climatic change manifests in the form of either severe drought or heavy floods. And our whole world is reeling under the impact of climatic change, and our country is also bearing the brunt of climatic change. And of course, our state is also not an exception. We had been facing floods, continuous floods for the past 3 years. So we need to have some curb on the usage of fossil fuels, and dependency on fossil fuels had to be reduced. So in this connection, you all may be aware of our climatic change convention held in Paris in the year 2015, and 192 countries have participated and took a resolution that they will strive hard to bring down the global warming temperature rise by 1.5 degree Celsius. And this was again reiterated in the recently concluded summit in Glasgow, UK, on COP26 summit. And here also, now different countries have fixed their targets. For example, China aims to become carbon neutral by 2060, and India also is aiming to become carbon neutral by 2070. So under these circumstances, our national transport and Indian railways also want to contribute their share also in reducing the emission levels, and they have fixed a target or aim to become net zero carbon emitter by 2030. So that's a background. Now let us go to the slides and see one by one. Now this you all know, Indian Railways is the fourth largest network in the world after USA, Russia, and China by network area wise. So whatever these salient features I'm showing is already known to you. Only to brush up, this slide is being projected. The whole IR network is covering 67,956 route kilometers. So there is a distinction between route kilometer and running length of the track. Normally, the running length of the track may be double to this. In fact, suppose you take a distance from Chennai to Arkonam, it's around 80 kilometers. But there are 4 lines, 2 for mixed traffic and 2 for EMU traffic. So both all put together will be 320 kilometers. But actually, route kilometers is 80. That route kilometers is being taken for evaluating this total route kilometers. So that's a figure you arrive at like that. In railway parlance, we always call the route kilometers. Then Indian Railways has got 7,325 stations across India. It operates 13,169 passenger trains daily, and around 8,479 freight trains daily. So its IR is transporting 24 million people daily and 3.3 million tons of goods daily. And it's one of the largest consumer of electrical energy. It consumes around 20 billion units annually. So if you equivalent to that, will be somewhere around 6 to 7 gigawatt. 1 gigawatt is 1000 megawatt. So 2% of the country's total power is being consumed by our national transporter. And 3 billion units, that is 15% for non-traction purposes, and 85%, that's remaining 17 billion units for traction purposes. And of course, Indian Railways are the third largest consumer of diesel fuel, and the annual expenditure on fuel is around 17,000 crores. And if you see among the all transportation sector, all put together, roadways, railways, seaways, and airways all put together, it's contributing around 12% of the GHG emissions of the national emission levels. And our railway is accounting for 4% of the GHG emissions. So carbon footprint is still is massive only. So this is the general status of our Indian Railways. And now we will see what are the opportunities for railways to switch over to or achieving this carbon neutral or net zero carbon. So one significant goal of achieving is 100% electrification of the entire rail network by 2023. So this is almost 70% of the network is electrified, and remaining 30% they have fixed a target of December 2023. So sufficient funds are already allocated. It will go through. There is no doubt about it. So by virtue of this complete electrification of our railway network, you will be saving around 2.8 billion liters of diesel annually, which results in terms of money saving of rupees 17,000 crores. So this is one advantage. The second one is we will be reducing, by not using these fossil fuels or diesel, we will be reducing the greenhouse gas emissions to the tune of 15 million tons of CO2. This is, of course, it could meet 5% of the India's nationally determined contribution target. So our nationally determined contribution target is somewhere around 300 million tons. So this 5% you will achieve from railways itself if railways were to go for 100% electrification, and if we are not using fossil fuels at all. So this is a commitment given by India to Paris Convention. So railways contribution is also appreciable. But once we switch over to 100% electrification, naturally, yes, we have to phase out all these diesel locomotives. We cannot run diesel locomotives once it is fully electrified. So this is a tremendous population in railway, around 5,256 or something. The actual figure I do not know, but is 5,000 plus diesel locomotives will be rendered surplus, and still 30, because only 70% of the network is electrified, still 37% of the trains are still running with diesel locomotives. So how are we going to tackle this problem? Once we phase out, we cannot use this. Instead of, you have to use electric locomotives. So what Indian Railways are proposing to do, there is a caudal life for this diesel locomotive. It is around 36 years. But now recently in 2019, committee reviewed and revised this caudal life, because maybe anticipating these things, and actually it was 36, now it is reduced to 31. So based on this caudal life, suppose the diesel locomotives which have already completed the caudal life of 80%, naturally Indian Railways wanted to condemn and scrap it. And the diesel locomotives which are having 50%, completed 50%, within 50 to 80% range, so they are thinking of disposing in the form of either selling it to other nations, or gifting it, or export. So whatever means possible, already having tie up with the rights and all, they are negotiating, is going to take place. But one catch is here, because all our diesel locomotives are broad gauge. So we have to see the countries or nations where BG is available, broad gauge is available. So such countries only you can sell or export or gift. And the diesel locomotives which have not served or not completed 50% of the caudal life, almost fairly new ones. So there are different proposals floating around. One is to convert these diesel locos into electric locos. Already this exercise was done in diesel locomotive works Varanasi, and converted to WDG3A diesel locos into a twin electric AGC3 loco. If you see this, W stands for broad gauge, D stands for diesel, G stands for goods train. Similarly, here W stands for broad gauge, A stands for AC, electric loco, and G stands for goods train, freight train. So this was already converted in 2019, and it was flagged off by our Prime Minister, Mr. Narendra Modi. And of course, here the expenditure for converting these diesel locos to electric locos was only around 3 crores or so. But the problem is that the labor content is high, around 65 to 70% is labor content. So now railways again toying with the idea whether we have to continue like this, because it has not shelved, but still they have some apprehensions because manpower is not available, because now the manpower will be allocated for manufacturing electric locos, more number of electric locos once we phase out these diesel locos. So manpower is a problem. Of course, again, outsourcing and things like that being worked out there. Now, progressively, Indian Railways are going to withdraw 2,600 diesel locos, and these condemned, as I told you earlier, once the diesel locos quarter life is completed beyond 80%, we will condemn it or scrap it. There you will get these DG sets. So we have to see what is the utility of these DG sets. You all know, once you change this fuel circuit and all, it can be made suitable for biofuel. And second, governor, DG governor, that electronic governor is also suitably changed so that it could be used for charging stations, where standalone charging stations for EV. Now EV vehicles are going to come in big way. So in that way, it will be beneficial. This idea is also being floated around. Now, as I told you, this DLW, diesel locomotive works, have completely stopped manufacturing diesel locos. Almost, I think 2018 they have stopped, and now renamed as BLW, Banaras Locomotive Works, and now they are focusing only on manufacturing of electric locos, like regular production like WAP7 and WAP9 electric locos. So this now, yes, you may ask me, what about some already in the pipeline manufactured? Yes, such shells are already available. WDG4 shells, only structure, but things have not completed in full-fledged manner. So those shells, they are converting into electric, WAG11 twin locos. So some few numbers are there. This already 4 locos have been made ready, and some are also in the pipeline. Few numbers. Now, next biggest hurdle for Indian Railways is there are some loco sheds, diesel loco sheds. 42 loco sheds are available and progressively getting converted into electric locos. Already that work is started, and some are already converted. Now, another thing is, now Indian Railways are planning to retain 700 diesel locos as a backup in case of any OIC breakdown or disaster management all. Once you don't have the power or OIC is not okay, then naturally we need to have some backup. So we will be Indian Railways will be retaining around 700 diesel locos. In the meantime, there is a diesel loco factory, Marhaura, Bihar. This is a joint venture with the GE Transportation US and Indian Railways that was signed in 2014 for production of 1,000 most energy efficient, low emission category, high power locos over a period of 10 years contract. This contract was already available, and now we cannot terminate it. So this is biggest headache for Railway Board. It's a conundrum. Now what Indian Railway is going to do for the 700 diesel locos which they want to retain, there this out of 1,700 will be utilized, and again 300, again that fate of that 300 still we have Indian Railways have to work out. So this is regarding diesel locomotives. Once we switch over to complete electrification. Now there are some 280 to 275 or 275 to 280 demo trains are there. The concept is wherever there is no electrification, to run multiple units, you have this concept of demo, diesel electric multiple units, similar to EMU. But here the problem is there won't be any YG, so you have to use your own power source for traction. So it's a diesel generator. So already 280 are there. So we have to either do convert this, or you have to phase it out. No other option, because once it is fully electrified, there is no point in keeping this diesel again polluting the atmosphere. So Indian Railway is inviting bids for converting 2 demo trains to hydrogen fuel cell PM. Already this tender floated. This is proton exchange membrane based traction for hydrogen fuel cell. This is for first, it will be run on Sonipat Jind section of Northern Railway, 89 kilometers. So 2 trains, demo 2 trains will be first converted. This tender is already floated. Depending upon the fate of this tender, because this is with technology transfer. Indian Railway is trying to have indigenous developed hydrogen fuel cell. So a lot of people are participating. So once this is successful, naturally this will be extended to diesel locomotives also, not only for demo trains. There also, where that's why they are not keen in converting to electric locos directly. So they are waiting for this also. Once this is successful, probably both for demo trains and diesel locomotives, the same strategy might be adopted. And now the demo trains turned out from ICF, I think since 2018 or 2017, all are fitted with solar panels, rooftop solar panels. There are 8 cars in a demo formation. So the all capacity will put together will come around 5 kilowatt. That will suffice the load of lights, fans, and the PI system. So in that way, to that extent, your diesel generator set need not contribute to this load. So naturally, there is a saving of energy efficiency. So saving of 21,000 liters of diesel annually for each rake, demo rake, making it more fuel efficient. But once you switch over to hydrogen fuel cell, of course, that again is going to be more beneficial. My screens are visible and my voice is audible, isn't it? Hello?
Yes,
oh, okay. Thank you.
You're audible, sir.
Okay. Thank you.
Sharing is okay.
Now there is another area where we are using fossil fuel is, you all would have known about Rajdhani and Shatabdi trains, where you have a power cast at the extreme ends, 2 ends. And that's a power source for feeding the full coach, full train, different coaches through a coupler. So we have DG sets, 2 DG sets in each power car, and both at the leading and trailing end. And around 600 kVA into 2, and similarly this side also 600 kVA into 2, 1200 kVA. So this now we have modified to HOG. The one which were using existing was EOG, called end-on generation. So end coaches will be generating, so end-on generation. Now we have switched over to head-on generation, HOG. Which is from the locomotive, electric locomotive will tap the power from the OHG itself. In the traction transformer of this electric locomotive, there is one more winding called tertiary winding called hotel load winding. That winding will take this power, and because you will have variations in that power, because though we call it as 25 kV AC, it can go from 18 kV to 32 kV at various times. So you have to have some constant voltage. So what we do? So we have some 500 kVA converters, electronic converters with IGBT version. So these converters will give 750 volts. That's the existing one. From DG set also we are getting 750 volts transmitted to each coach. Same way, similar fashion, you have these converters also giving this 750 volts through couplers. So only thing, instead of DG set supplying this, you get it from the overhead line YHE itself through your loco, electric loco. There are multiple advantages. One advantage is since there is no DG set, the release space is used for accommodating differently abled people and parcel room. So more space you are getting. Second, reduction in noise pollution and GHG emission, because you are not burning any fossil fuel. And reduction in fuel usage results in saving of 1100 crores all put together. That's 580 for trains. And compared to end-on generation power, which is 22 rupees per unit, this HOG power is very cheap, 6 rupees per unit. So by these three methods, complete electrification, you will never run diesel locos, all getting converted into either form of selling or disposal, and demo converted to fuel cell model, and EOG to HOG. Straight away we are avoiding fossil fuels. So this is that's why these are all some of the already benefit plus points for the Indian Railways. Already you can easily work it out. Now, so far, whatever we have talked is we will not be using fossil fuels either two. So hereafter we will not be using fossil fuels. Now we will go for more energy efficient. Indian Railways is going to go for more energy efficient locomotives, EMU trains like that. So the method by which Indian Railways is going for energy efficiency is regenerative braking, adopting regenerative braking in all locomotives and EMU trains. That helps Indian Railways to save more energy, save energy as well as money, both. So all modern locomotives, state-of-the-art locomotives, WAP 5, WAP 7, WAG 9, WAG 12, all are having regenerative braking features. So there is no problem. But there are some electric locos which are earlier version were not enabling or not suitable for regenerative braking. There we have retrofitted with the help of BHEL, and one pilot project was done and is successful. And this will be extended to all WAG locos of earlier builds. Now let me talk about the regenerative braking. See, normally the kinetic energy of the train is utilized for braking by making the motors, because ultimately the hauling power comes from the motors. The motors will be made to run like generators. If it is an induction motor, induction generator generation will take place by using the kinetic energy of this train. Then once the generated power from the generator, that's actually a machine. Now the motor becomes a generator. So that generates during braking. Braking force is also, braking effort is also coming. At the same time, the power is also generated. This braking power, the generator power, is fed to the YHE. So when the line is receptive, any electric locomotives or train or EMUs coming in that section, naturally it will be utilized by that particular locomotive or EMU train, but it will never go to the substation. So that's why I told the line should be receptive. And this for all EMU formations, electric bulb which are running in Mumbai Suburban, is all manufactured since 2009 with regenerative braking, and we have estimated that it's a saving of 30%, and in terms of money, saving of 1 crore per rake annually. So if you take both the Central Railway and Western Railway put together, around 280 to 290 rakes will be there. So that much of 290 crores are saved annually. That's the advantage of regenerative braking. So once electric traction comes, means all these features can be adopted, and you can make it more energy efficient. Now another area where you can have more energy efficient is dedicated freight corridors. Already Indian Railway is going ahead with 3,306 kilometers high speed and high capacity rail corridor, exclusively meant for transport of freight. So the advantages of DFC is it enables port connectivity because dedicated lines. So there is no mixed traffic. Mixed traffic means both passenger and freight. So now this enables port connectivity, decongest the existing IR network, Indian Railway network. Then another advantage is you can increase the speed. Now you all know a goods train or freight train is average speed is around 30 to 40 kilometers per hour. Now you can increase to 70 kilometers per hour and faster mode. And another advantage is now these all dedicated freight corridors were made with keeping in view of double stack container train. That is, two containers can be stacked one on the above. So YHE and all is made to suit this type of double stack container, and even bridges and all that height is maintained. So that's the advantage. So the concept is something like running longer and heavy haul trains with higher axle loads. So our Indian Railway axle load is around 25 tons for goods and all. Now increased to 32.5 tons axle load. Now, by virtue of this overall reductions in greenhouse gas emissions from transportation sector, by shifting freight to rail, optimizing truck usage and all. Now, dedicated freight corridor means most of the freights from road also can switch over to rail. That possibility is there because faster, longer train with faster and also more capacity and connecting all important nodes, port connectivity and important stations and things like that. So it becomes more friendly, user friendly. Then of course it reduces the logistics costs of gross domestic product. So with this, there's an improved performance, throughput is also increased, more energy efficient. So these are the things which railways is focusing. But now only some, I think some 700, 800 kilometers only completed. A long way to go. By another 3-4 years, this should be completed. Now another area where railways are focusing is they are adopted multi-pronged strategies to reduce the cost of power procurement. So reduce the energy consumption, then reduce the cost also. So what are the methods available for reducing the cost? You all know earlier railways, Indian Railways are the consumer. They used to get it from discoms of state electricity boards. And now they have migrated from discoms to a deemed licensee, enabling open access procurement. So of their choice, they can get the power. So this is one advantage. So by virtue of this, a lot of saving is coming up. Now another have own captive power plants, have own transmission networks, improve efficiency of the power utilization, and harness more and more renewable energy. So these are the multi-pronged strategies going to adopt for another 2-3 years. Now this power procurement from open access. IR purchases power under open access as a deemed licensee in 11 states. Already NOC, non-objection certificates, have been obtained from 11 states where Indian Railways is deemed licensee, and they only paid wheeling charges to these states, electricity boards, and they are purchasing from anybody of their choice. And this is not the end. there will be gradually migration from consumer to deemed licensee in other states also. This will be extended to other states also. And by this enables railways to buy electricity from generating company by paying billing charges to the central and state transmission system. By adopting this, I think this was adopted right from 2015 onwards, 14 and 15. So already Indian Railways are saving tremendously. 50 megawatt from UP Vidyut Nigam Limited, from where they are purchasing, and through connected through CTU network, and saving around 100 crores per year. CTU Central Transmission Unit. Another 500 megawatts from Rajasthan Gas Power Private Limited, and it is wheeled through Maharashtra, MP, Gujarat, and Jharkhand, where they are already having NOC for wheeling. Then saving around 1,000 crores per year. Then 90 megawatts from Tata Power purchasing directly from Mumbai for 150 crore per year, and 585 megawatts of Jindal India Thermal Power through two states, MP and Rajasthan, is saving around 1,000 crores per year. So this exercise has already started, and this will be extended to other states also. Then naturally the savings are going to be more. So through open access, I are taking around 1,400 megawatts of power under open access as deemed licensee, and results in saving altogether saving of 3,500 crore per annum. And this is going to likely to be increased in near future. And Central Electricity Regulatory Commission has already given approval for more states are coming on board in allowing non-objection certificate to IR for procurement of electricity from the supplier of its choice. So once all other states are also included, naturally the savings are going to be tremendous. Then one captive power plant Indian Railway is having tie-up with NTPC. It's called Bharatiya Rail Vijli Company in Nabinagar. So 250 megawatt for units. So almost 80% of the power is being utilized by railways, and 20 is for local usage and all. So that's MOU. Then, as I told you, Indian Railways to set up 8,500 kilometer transmission dependence on state discoms. So this is a major plan which Indian Railways are envisaging. So naturally, this 400 kilometers Delhi to Kanpur already operational, 200 kilometers Kanpur to Allahabad already operational. The others 2,200 kilometers Delhi, Chennai, and Delhi, Bharuch, and Howrah, Mumbai, the Mughal Sarai and Howrah and all under progressing. It's all progressing. For this, there is a company called Railway Energy Management Company. He has already have an MOU with Power Grid Corporation Limited for construction of 132 kV transmission corridors and completed. So they are only negotiating with PGCIL, and they are undertaking these jobs for 220 transmission lines. So I would say 2 words about REMCL. See, actually, that's a joint venture company by Ministry of Railways and Rights. It's called Railway Energy Management Company Limited for undertaking projects of Indian Railway related to harnessing green energy, power trading activities, transmission lines, power evacuation, planning, energy conservation initiatives, efficient coordination in power generation through captive power plant, and energy audits. All these jobs are being done by this company. So really an asset to Indian Railways, and they are on this job. So more energy efficient and energy saving and money by these methods or strategy, Indian Railway can go ahead with that. Now we have talked about different things. Now next stage is harnessing renewable energy. How much we can harness? So Indian Railway plans to install 20 gigawatt. 20 gigawatt, 1 gigawatt is 1,000 megawatts. Huge, of solar for both traction loads and non-traction loads, feeding solar electricity into the OHE would be more effective than buying that green power from the grid. And one advantage with Indian Railways is they have got unused land, tremendous area of unused land, 51,000 hectares of land identified for provision of these solar panels. So more than 7,000 station rooftops are also being used. And the plan is something like this. IR initially plans to set up 3 gigawatt of solar plant in unused vacant land in 3 phases by 2023. First phase, 1.6 gigawatt for open access states under PPP model on DBFOT, that is design, build, finance, operate and transform model. And second phase, 400 megawatts ownership model of RAM, this our company RAMCL, eligible for capital subsidy under central public PSC, public what do you call enterprises, public sector enterprises investment scheme. Then third is 1 gigawatt along tracks under PP model on DBFOT model. Okay. Now these are the breaks up of whatever solar work being carried out in Indian Railway. Work of 50 megawatts solar begun in Bhilai, and this power will be wheeled to traction substation. So railways are concentrating for both non-traction purposes as well as traction purposes. For traction purposes, they are trying to wheel it to direct traction substations. So instead of buying green power from the respective EBs or power generating companies, so this is going to give more leverage to Indian Railways to have more energy efficient. Then renewable energy already harnessed by Indian Railways is around now as on date is 230 megawatt. The breakups are 121 megawatt rooftop solar already executed, and 6.7 megawatt ground solar executed, and 103 megawatt wind energy already executed, and 233 megawatt under progress, and 2,850 megawatts for ground solar is under progress. So the breakup of 103 megawatt wind energy is 21 megawatt in Tamil Nadu, 56.4 megawatt in Maharashtra, and 26 megawatt in Rajasthan. So already Indian Railways have installed 230 megawatts of solar plants. Sorry, or both put together, solar as well as wind. Wind contribution is 103. So Indian Railway is committed to using solar energy to meet its traction power needs, becoming fully green mode of transportation. And now, as I told you, for traction purposes, this one exercise was already done, a joint venture with BHEL, commissioned 1.7 megawatt solar plant at Bina, and can directly feed power to TSS, traction substation. So this already tried and successful, and this will be extended to other wherever open area you have solar panels on the track side. This can directly feed TSS, traction substations. Then another plan mooted out by Indian Railways is they are going to harness around 5.2 gigawatt power could be directly harnessed from trains. All on the rooftop of the trains, at least 1 in 4 trains. If you provide, that itself will be a tremendous quantity. When we say it around estimated that 5.2 gigawatt of power could be directly harnessed from train rooftops. All the trains will not be 1 in 4 trains. Suppose 4 trains are only 1 they will provide, 3 will be as normal. So by that method itself, they can harness around 5.2 gigawatt or 5,272 megawatt. Now, I think I am coming to an end. There are a lot of opportunities for Indian Railways. As I told you, as I mentioned earlier, Now, there are some challenges also. One is open access. I told you only 11 states they are having NOC. They should get NOC for open access of flow of electricity from other states, not operationalized due to regulatory issues, and they are pursued rigorously by IR. The other states are West Bengal, Tamil Nadu, Karnataka, Kerala, Andhra Pradesh, Chhattisgarh. All these states have to be roped in. So that is the biggest challenge for Indian Railways. Then another wheeling and banking provision by all state electricity boards for full deployment of solar potential. Though Indian Railways have the capability and capacity to do it, but again, the transmission lines and wheeling and banking provision and all to be done by with the cooperation of other states, state electricity boards and discoms. So that is another challenge which Indian Railways face. Then another is availability of banking, as I told, facility and merger of solar and non-solar applications. Now, renewable energy obligations are there. When you are consuming some X quantity, some percentage of that should be always renewable energy. And this mix-up also to be relaxed so that Indian Railways can flourish in solar deployment, solar panel deployment. Then net metering, some restrictions are there. I think now it's 500 kilowatt. Beyond that, you don't have net metering. So that also to be lifted. Unrestricted net metering regulations also to be there. So though we have a lot of opportunities, same time some disadvantages also there, challenges are also there, which Indian Railways have to meet. Then only this aiming for net zero will be successful. So with this, I will conclude. Thank you for patient hearing. Thank you very much.
Thank you, sir. That was truly a great session. Sir, we have some questions in the chat box. So
Yeah,
shall I
please.
read for you?
Yeah, please.
Okay, so the first question is from Rohan Damodar, and the question is, sir, are WAP7 and WAP5 the only locomotives that supports HOG?
No, HOG, now most of the locomotives, electric locomotives, which have not got this, that is hot and load winding, that we have to provide. And whatever these 585 trains, we have a population of locomotives around 7,000 electric locomotives are there. From that, you will take a number required, which are already having the provision of hot and load winding in the tertiary winding in the transformer. Those locomotives will be selected and used for HOG. From 7,000, not 1 or 2. You require only 585 trains. So there is no problem. There are, as he has doubted, there are some locomotives that doesn't have this hot and load winding in the traction transformer.
Okay, thank you, sir. And so the next question is, sir, when would WAG11 come into service?
Now trials are going on. Two locomotives are already in trials that are being run in some railways, northern side. And after studying those features, then naturally, then other things will be streamlined.
Okay, so the next question is from Ravindranathan, sir, and the question is, any impact on the passenger safety with the change in power source from diesel to electric?
Absolutely not. Absolutely. Electric traction is more because you have got the regenerative braking. We are using the power of traction motors for braking purpose. Electric braking is an electric braking. But actually, in all trains, you have got both braking. It's actually blending. Brakes are blended. One is the EP brake, and other is a regenerative braking. Normal trains where there is no electrical braking, we go for only EP braking. Both are there. Both will be blended and used because certain speeds, for example, if the train is running at some, let us say, 15 kilometers per hour and all, regenerative braking may not be effective because kinetic energy is not there. So in that case, EP braking will be used. It's blended. So that's all done by the brake control unit. So it's a microprocessor based system. where it calculates how much is required from electric braking, how much is required EP. So accordingly, it apportioning it.
Okay, so the next question is from Rohan Damodar, and the question is, sir, what's your opinion on the latest EMD WDG 4G diesel locomotive?
No, I don't follow that question.
What's your opinion on latest EMD WDG 4G diesel locomotive?
Diesel locomotives are going to be phased out. No? You are talking about that new locomotives going to be manufactured. That is still numbers have not been given, which I told you now. General Electric diesel locomotives. That only 1 or 2 are in manufacturing stage. So that will take around 10 years. Now only, though contract was awarded in 2014, all other formalities were finished, and factories setting up is there. Factories now it's set up. So it will take time. But this particular model, I'm not sure. It's not the latest one.
Okay, thank you, sir. And the next question is, has EMD locomotives proved better in reducing carbon footprint and emissions compared to ALCOs?
Talking about diesel locomotives, no? Diesel locomotive. No. Comparing your diesel locomotives to air, isn't it?
Yes, sir.
Okay. Now, this one, the latest one, which 1,000 locomotives, which Indian Railways have a contract with GE, that is more energy efficient and emission less, very less. But others are all normal. Maybe I don't know. That air aviation fuel quality and how engines behave and all, I don't have any idea. So comparison with that, I'm not competent to make it. So sorry, I may get the answer after some time, after going through some books and all, or some discussing with others. So presently, I'm not aware.
Okay, so the next question is, sir, shouldn't all coaches of trains with ICF coaches be convertible to LHB to make it HOG compatible?
Yeah. Now a decision has been taken by Indian Railway that all ICF coaches, design coaches will not be run in Indian Railway network. All will be with LHB. Even now ICF and all the 3 factories, Raebareli and RCF, all are manufacturing only LHB coaches, and whatever old coaches of ICF design are getting phased out. So maybe another 2-3 years may run, and further it will not run.
Okay.
So only LHB, and because it's more safety on safety standards, LHB is far more safer than ICF old bills.
Okay, so the next question is from Ravindra Dadan, sir, and the question is, in case of an unforeseen accident, how the safety of the passengers from the possible electric short circuit conditions?
Short circuit never happened so far, because we have got all 3-tire protection, 4-tire protection and all there. So short circuiting has never happened. I don't have any.
Sir was asking about an accident, sir. Unforeseen accident time, how the electrical protection is ensured.
Accident time means actual 2 coaches collision, or 2 trains collision, or YHE snapping on the coach, or something like that. YHE wire snapping on the coach. Is it like that? Accident means what?
It can be like that. It can be, for the discussion purpose, we can consider like that, sir.
Oh, that is YHE snapping and falling on the roof of the train or coach, isn't it? So immediately circuit breakers will trip, and not only that, from the traction substation itself, power will be switched off. It will not be live. That wire will not be live, and that even milliseconds it will trip, because that's a protection ensured by substations. when OHE is done. But only thing, if initial while falling on the coach, if some spark takes place and some vulnerable objects are inside or something like that, like fuel or kerosene or something like that, then it can lead to a fire accident.
Okay, so the next question is from Krishna sir. What is the maximum efficiency of regenerative braking practicable? Are we able to employ capacitors?
No, regenerating capacitors is already there. Actually, to take induction motor, three-phase induction motor, you have to give reactive power. Reactive power is given by these capacitors only. Already capacitors are there in the circuit. So we have a method called VVVF, variable voltage, variable frequency mode of speed control. So this induction motor will run as a induction generator at the time of regenerative braking. So the reactive power needed for that is given by these capacitors. Already in the your bank, capacitor bank is there, that will be aiding this. So already capacitor is there. And I think you would have studied in colleges, normally there is a relative speed between your rotating EMF of the stator and the actual rotor. That is called the slip. If the slip is positive, it is motoring action, and if the slip is negative, it is a generator action. So you are making the slip negative and making it as generation.
Okay, and the last question is, in the latest high-speed bullet trains, what types of engine is used and what are the measures for safety, energy saving?
Bullet trains, you would have noticed our EMU trains, EMU format, three-phase EMU, same format only, same thing, regenerative braking and all, but controls will be more sophisticated and driverless concept with a lot of sensors and other things. So slightly sophisticated. Other than normal, our EMU, what is running in Mumbai, or you can compare this with our train 18. But with that's a semi-high speed. This is speed potential is very high, 300 plus kilometers per hour. But safety and all is ensured in all train operations. There is no doubt about safety and all. Safety is always ensured, because you, unlike other systems, here you have backup, 2-3 type of 2-tire backup, 3-tire backup. If this is not working, that will work mode. Then all automated mode fails, means there is a manual mode available. So safety is not at all compromised in Indian railways, because it's a serious thing now. You are taking thousands of passengers in a train, so you can't afford to compromise on safety. So safety is paramount importance. Still, some unforeseen, like carrying, again, people only carrying kerosene and explosive material inside the train, catching fire. And short circuit very rarely takes place, because coaches and all, a lot of protection, lot of different levels of protections are there. And most of the materials used inside the coach are fire retardant materials. So a lot of things are taken care. But still, I don't know, still scope for improvement.
Okay, thank you, sir. So the next question is, instead of supercapacitor bank, is there possibility of sending power bank to grid as alternative? Follow-up of the previous question.
No. This whatever generator power cannot be fed back to the grid or even substations, because that has to be there is no provision in our system, and the technology is also like that. And I think in DC, Cochin Metro, these people wanted, but I think they have not done that. They want to take this regenerator power back to the, because in metros and all, very few trains run. But our network, one train goes behind, another comes. So the line is receptive. Naturally, whatever regenerator power is immediately taken by this next train or EMU or whatever, because that area itself, it may not be the line, the full area, that zone will be consuming this regenerated power. So there is no need to take back to grid or substation. Whereas metro, I think Cochin Metro, I don't have. Initially, I was following it up. Then I lost track also. They were trying. There's some tender they floated with Alstom and all, and successful or not, I don't know. I didn't follow it up further.
Okay, thank you, sir. So I hope all the questions are. Okay, there is one more question.
Sir, you were mentioning about fixing solar panel on the rooftop of the train. Sir, it would be more appropriate rather than fixing on the rooftop. Can we go for like you told, we have got a lot of barren land, Indian Railway land. Why can't we go ahead with that alone, fixing solar panel there and feeding the whatever generated power to the main grid or OICs, then use it. If we go for fixing the solar panel, we will be unnecessarily carrying a mass that need to be accelerated. Then we have to go for some kind of fixing there. For fixing, we have to tinker the whatever available. So it would be more appropriate to have a fixed panels on the ground than the panels on the coaches. What is your view?
Correct. That I already mentioned. We have got 52,000 hectares of vacant land that is already identified. That's all used now. There you have to. They are going ahead with. Land using land, solar panels will be installed, and that will be feeding the traction substations directly. These trains and all is only for harnessing more beyond this. I told you, around 5.2 only you will get. If you do 1 out of 4 trains, you will get only 5.2 gigawatts, whereas 52,000 hectare land, if you harness, that's why we have aimed for 20. I'm sorry, I'm retired, but I'm saying BB in single relay. Aimed 20 gigawatt. 20 gigawatt is the total power we want to generate. Indian Railways want to generate. So 20 gigawatt, you can assume this is only 5.2 from train, but all other things are coming from station rooftops. Now only 1,000 stations they have completed. That itself comes to 100 megawatt or so. Remaining 6,000 stations are there. Station rooftops easily you can provide, and it's going to serve for 20-25 years. And similarly, vacant land. Vacant land means very easy to transport substations. On the track side, we have got a lot of land. Indian Railways have got 52,000 hectares already identified. So potential is there, and opportunities are also there. But only thing again, whatever you have generated, how to wheel it? No, wheel it to required place. That's the problem. That's the challenge which Indian Railway is facing. There is no depth of capacity and other things. There are plenty. That's a problem. Wheeling and banking is a problem because they have to get NOC from other states. Though it's a deemed licensee, still they have a problem.
Okay, thank you. Sir, is there any questions? Okay, so I hope all the questions are answered. Thank you so much, sir. You have patiently answered all the queries that had arrived.
No,
thank you so much.
Okay, thank you very much. Thank you for patient hearing. Thank you very much. Okay.
So now let me call upon Atmaja to deliver the vote of thanks.
Am I audible, sir?
Yes.
A warm evening to one and all gathered here. Most valued guest of honor, Madana Mohan K, and all other esteemed dignitaries and dear participants. I am much privileged to propose the vote of thanks and acknowledge the contribution those who work hard to make this 102nd Intersociety weekly webinar series into a huge success. On behalf of IWWS, I exhibit heartfelt thanks to our chief guest, Madana Mohan K, who spent his busiest time lightening the occasion. Your thought had really enlightened us, and it was really mind-blowing. As a token of love and honor, we would like to present a virtual memento. Kindly accept it, sir.
Okay, thank you. Thank you very much. Thank you very much.
Thank you, sir. Special mention to Dr. Ravindranathan, sir, respected chairperson of IWWS, being the backbone of this event, who inspired us to do our best and stand as a pillar of power. Thank you, sir. I would also like to express a sincere gratitude to the people behind the scenes who helped to execute this event, especially technical arrangement team. Ms. Nova Stebby, the moderator of the session, Alan for the welcome speech, and Gogul R for the introduction. At the end, I express my sincere thanks to all the participants who gathered tonight. Your active participation was the success of this webinar. Once again, thank you all.
Thank you, Atmaja. So before we conclude, I would like to say one thing that the 103rd Talk of Intersociety Weekly Webinar Series will be on 30th of March, which will be handled by Dr. Kuncharia P. Isaac, and the topic will be the NEP and the desirable changes in the education in Kerala. So hope we'll meet on that day. So thank you all for joining us. Thank you.
Thank you. Good night.
Good night.